So you asked ChatGPT to write a rap song about oxygen on the moon.
Yes, about extracting oxygen
Oh,
from the moon.
excuse me.
Yeah.
Aren't you supposed to be busy with real stuff?
Yeah, these are the stuff you do in bed when you go to sleep between emails. Let's find it.
Can I ask while you look for that on the promotional video of the company? Is that Morgan Freeman's? Is that Morgan Freeman?
No.
No. So, because it sounds very much like Morgan Freeman talking.
Yeah.
Talking about oxygen on the moon, but that's not him. Who is that?
It's some professional narrator. But yeah, we thought what can be like a good voice to give you the feel that this is all going to happen.
Yeah.
Like if God will tell you this, there's nothing better than okay. I found the song. So this is how it goes.
Okay.
In the craters of the moon's dark face, we mine for oxygen. To fuel our ships in the dusty regolith, we extract the air we need to make our trip. With machines and tools, we break the ground and electrolyze the regolith to be found. In the thin, frigid lunar air, we breathe and toil without, without a care. For this is our mission, our great quest, to mine for oxygen and make the moon our nest. We will not falter, we will not tire in this quest to make the moon our home. We are the miners, the oxygen keepers, bold explorers, forging new paths. We will not falter, we will not tire in this quest to make the moon our home.
Okay.
GPT. Yeah.
ChatGPT. You should marry like a Churchill voice to that rep and see and then put that on your website as well, I think.
Yeah.
So you're selling oxygen on the moon.
Not yet. Will be.
Well, that's what your LinkedIn profile says.
Yeah.
What the hell does that mean?
So, humanity is going back to the moon in the coming years.
Okay.
I mean, we're already sending robotic missions to the moon. Artemis 1 mission 1 was launched just a few weeks ago. First astronauts to the moon are going to step their foot there since 72.
Wait, so back up for a second, because what's been going on since for me, like the whole history of space travel is Neil Armstrong, something,
Yeah.
Elon Musk, like that's kind of where we are. So fill me in what the hell's happened in the meantime?
Yeah, no, that's a great question. This is exactly what I asked when I started this.
Okay.
So yeah, we had the Apollo program back in the 60s, 70s.
Yeah.
It ended with Apollo 17 in 1972.
Mm-hmm.
Last astronaut stepped foot on the moon. And that's a great question. What happened since then? Where are the lunar bases that everyone promised us? And,
Yeah.
all the expeditions and then to Mars, etc. So we had a whole bunch of scientific missions. Martian rovers, orbiters. We had the shuttle program. I mean, the U.S. had the shuttle program. We built the space station, the International Space Station, Hubble telescope. These are all major milestones that humanity, led mostly by the U.S., had between Apollo to Elon Musk. Okay.
But in that time, humanity stopped sending people to the moon.
Yeah.
When was the last time an astronaut set foot on the moon?
72.
72?
Yeah.
It's been 50 years?
Yeah.
Oh, wow.
Mm-hmm.
Okay.
Yeah.
Wait, and all this stuff about like Blue Origin and SpaceX, people haven't been actually walking on the surface of the moon? They're just...
No. SpaceX is the Dragon, the crew capsule, Dragon crew capsule. That one takes astronauts to the space station, not to the International Space Station, the ISS, not to the moon.
Okay.
So the Chinese made some significant progress. They've been roaming around with their rovers on the moon for several years now,
Okay.
on the far side mostly.
Meaning, what is the
The
far
side
side?
that is not facing Earth. I mean,
Okay.
when you look at the moon, it looks the same. Not you're not right. The the dark spots, everything looks the same because you always see the same side of the moon,
Okay.
because the moon is what's called tidally locked. It's rotates, orbits around Earth, facing with the same side to Earth, and you have the far side always the other way.
Okay. This is gonna be the first of many stupid questions, but does it matter where you are standing on Earth? You always see the same side of the moon?
When the moon is above the horizon, yes, you'll always see the same side. You
Okay.
always see the same side of the moon.
Doesn't matter where you are in the world.
No, no,
Okay.
doesn't matter.
Okay.
No.
So no one's been walking around doing jumping jacks on the moon
No,
for
since
50 years.
yeah,
Okay.
50 years, and now we're going to have first astronauts since then going back to the moon under the Artemis program,
Yeah.
which is the successor of Apollo. Um, and SpaceX is going to have a key part in this because they are going to build the HLS, the Human Landing System,
Okay.
which is the spacecraft that will literally take the astronauts down to the ground, which is going to be based on a Starship, which is a very big vehicle.
So why do they need to invent something new when humanity managed to do this 50 years ago?
So there are a lot of reasons for this, but I think, in my opinion, the main issue is safety. How much you care about safety. Okay, so back in the Apollo era, if I'm not mistaken, um, the safety rating of the system was around 50%, meaning the astronauts knew that they're going to the moon with 50% chances of going back. Something like that.
Okay.
Okay. Give or take. I mean, today, that during the shuttle era, that was 97%.
Okay.
Okay. Which, by the way, in retrospect, was quite accurate in terms of we had two major disasters,
Right.
the Challenger and the Columbia, and they account to around 3% of the total launches.
Okay.
Um, Today, it's probably more than that. Now, every additional digit or like a number there like requires way more effort to make sure you can meet these requirements. It's exponential. It's not linear.
Hmm.
Like the difference between 99 to 97% is much greater than the difference between, let's say, 60 to 50%.
Right.
Okay, like significantly greater.
Mm-hmm. Mm-hmm.
So if you want a vehicle that will be 99% safe, that's no way something that could have been done 50 years ago.
Mm. Oh, and what? Just so I'm clear, what explains that? Um, that delta, right? To close the gap between, let's say, 90, that last 3% versus going from 50 to 60
The
percent.
reliability of the parts, the advanced composites that we have today, the advanced computing that you have today, a lot of automation. You can get rid of most of human errors in the process. The tests, the validations you can do to your systems before launch is way greater than what could have been done back then.
Mm.
Um,
Oh, so you're not saying that it's much harder. It's just the amount of um computing power and brain power that we have now is far far greater, and that's that can.
yeah, no,
Okay.
but it's also harder.
Okay.
I mean, it's hard. It's hard when you build um, a engineering system. Okay, when you engineer a system and you don't want it to fail. Okay, and you're going to take it to an uncharted territory.
Mm-hmm.
Like there are so many things you don't know that you don't know.
Yeah.
So how can you account to, all the possible things that can cause your system fail? So, for example, and this is something that Elon Musk said in one of the tours that he gave, I think, to Tim Dodd, the everyday astronaut.
Mm-hmm.
There's this great episode in Starbase, and he says that with Starship, so they had many failures, like it really exploded time and time again, and they really tried really hard in advance to think of all the possible ways this can fail, so they can measure it and then improve the next iteration.
Mm.
But every time it failed for a reason they did not foresee.
Right. Okay.
So that's part of it. To try to cover all your bases to make it work in the first time.
Mm.
That's pretty an amazing feat to do, and you don't have that luxury to fail when you have astronauts on board.
Right. Right. Okay. So that explains some of the reason why no one has been setting foot on the moon. It's just
That's and the lack of
we're more risk
incentives.
averse. Oh,
Also,
last. What do you mean?
I mean, back then it was the Cold War. Was this competition, a race to the
Yeah.
moon between Soviet Union and the U.S.? Now we're seeing this again with China and the
Oh.
U.S. Yes, like I think a month ago there was published about this small conflict they have on a specific location. Both of them want to establish their first base on the south pole of the moon.
Yeah.
So yeah, that's like the ultimate vantage point, the moon.
Isn't that weird though? Like we need not silly, but like terrestrial politics to get us up and moving about
Yeah.
exploring territory outside of our planet.
Yeah.
Okay, so but let me just come back to you because so trying it anyway to sell oxygen on the moon. First of all, yeah, explain that. Like what does that mean?
Yeah, so now that we established that we're going back to the moon,
Yeah.
We'll need a lot of mass, a lot of materials and equipment. The idea is not just to stick a flag and go back now, but to actually eventually establish permanent infrastructure.
Yeah.
And the most sought after material by far is going to be oxygen, not to breathe. Breathing is going to be a very small part of this, but to burn propellant.
Mm-hmm.
Okay, so this is something that most don't think about, but when you burn something, right, you need the propellant itself, the fuel or whatever. You need heat, a heat source, and you need oxygen. Now, when you do it here on Earth, we don't think about it because you have indefinite amount of oxygen in the atmosphere. So, for example, if you're going to burn methane, okay, 1 kilogram of methane, it will suck from the air about 4 kilograms of oxygen.
Naturally.
Yes, that's what it needs in order to burn.
Okay.
So when you go to space, you need to take that oxygen with you. Now, it's not an exact ratio because on purpose they want to have a bit less oxygen, so the reaction will be a bit cooler. But still, for every ton, let's take Starship as an example. Starship, for every ton of methane it burns, it requires around 3.5 or 3.6 or 7 tons of oxygen on board. And the oxygen in the propellant is by far most of the mass. It's nearly 85 or 90% of the total mass of the whole vehicle. So you have this huge system. Only the upper part, only the Starship itself, the one that will land on the moon and Mars, etc.
Mm-hmm.
So when it's fully loaded, it will weigh something like 1,400 tons.
Which is, in human terms, what like
1,400 tons?
10 cars, 100 cars?
Yeah, a car is like, I don't know, half a ton.
Okay.
It depends what your car is.
So 2,800 cars.
Let's say. Yeah.
Wow.
So you have 1,400 tons. Okay, it's the
and this
high.
is just one.
This is
one
just
rocket.
one. This just one rocket. Now the dry weight, meaning the weight of the vehicle itself,
Mm-hmm.
is only 100 tons.
Okay.
Okay. Then you have the cargo, the astronauts, and whatever. That's another 100 tons.
Mm-hmm.
And then you have 1,200 tons of propellant and oxygen, and the ratio between them is 250 ton of propellant and 950 tons of oxygen.
Right.
So that is most of the mass, and they will need to refuel in orbit. They'll need to refuel on the moon. They'll need to refuel on Mars. They'll need to refuel in many places. And if you can get that oxygen not from Earth, okay, outside of what we call Earth gravity well,
Okay.
you can dramatically reduce the costs of these operations because most of the cost comes from the need to overcome Earth gravity.
And,
That's
okay. And stupid question number 2.
Yeah.
There's gonna be many of these, but there's no oxygen outside of the Earth's atmosphere.
in space. So no, so in just empty space, no.
Okay.
So the most accessible oxygen beyond Earth, as we see it, is the lunar ground.
Mm.
Like on the moon, you don't have atmosphere; it's just vacuum, the vacuum of space. I mean, you do have something, but it's negligible. Um, and the ground is made of a bunch of minerals.
Mm-hmm.
Okay, just like here on Earth,
Mm-hmm.
same oxides, and the professional term is regolith. That's the regolith is like the broad term for this type of sand or soil. Or okay,
Okay.
and practically what you have there is a whole all types of different metals that are chemically bounded to oxygen.
Meaning.
Meaning you have iron oxide,
Okay.
which is iron bounded to oxygen.
Mm-hmm.
You have alumina, which is aluminum oxide, aluminum bounded to oxygen. Silica, silicon oxide, silicon bounded to oxygen. Same thing here on Earth. The white sand you see on the beach,
Yeah.
that's silica, that's silicon bounded to oxygen.
Mm.
The red soil you see in the desert, that's mostly iron oxide because it's reddish.
Okay.
You have green sand.
Green sand.
Yeah, like in the craters in the Negev,
Okay.
you know, the big crater, small crater. You have like all these different types. You should go there. So that's copper oxide.
Okay.
Um,
Copper is green.
no, but when it's oxidized, it is.
Okay.
Depends. Like you have different levels of oxidation. So never mind for now. Anyway, the idea is that when you scoop,
If you think that I'm too stupid to understand, it's probably true. So it's fine.
no, I don't think. It just we can have talk for 5 hours just on oxide. So
Can you do that? Can you really talk for 5 hours on? I'm just curious. How long do you think you could talk about?
probably no 5 hours is an exaggeration. I mean, in my team for sure, I have some team members who can talk days on oxides. Myself, I probably can talk. I don't. My knowledge is not that deep, so I can probably talk like an hour. Something like that.
Oh God, I wonder what your wife must have thought on the first date. Anyway, go on.
Yeah. That's a whole different talk by itself. Yeah. Anyway, so yes. So what it means is that when you scoop some of that sand,
Yeah.
let's call it like that, nearly 50% of what you hold in weight is oxygen.
Mm.
Okay. Same thing here. Go to the beach or to wherever, scoop some soil, sand, gravel, whatever. That's between 40 to 50% oxygen
Mm.
by its mass, by weight.
Okay.
Also true on Mars, also true on Jupiter's rocky moons.
Hmm.
Okay. So what we're doing, we're separating the oxygen from these metals. This is not a new concept. Humanity have been doing it for several millennia. This is how we produce metals.
Right.
Like iron, for example.
Yeah.
Iron in nature is oxidized. meaning it is bounded to oxygen.
Mm.
And the way we've been extracting the iron from the iron oxide 3,000 years ago also is by introducing carbon to the equation.
Mm.
Okay, carbon back then it was in the form of wood. Today it's mostly coal and all sorts of natural gases, mostly methane. And what happens at above a certain temperature, usually pretty high, 1200 degrees Celsius and even higher, nature would prefer to have the oxygen together with the carbon and not with the iron. Okay,
Okay.
that will just happen.
Mm-hmm.
The oxygen will just move to the carbon,
Mm-hmm.
and then you'll be left with iron
Mm-hmm.
and carbon dioxide. Now it's carbon together with oxygen,
Mm.
you get carbon dioxide.
Mm-hmm.
This is why, for example, the steel industry, which is where all the iron is made, is responsible for nearly 10% of humanity's carbon footprint
Right.
because of that reaction I just
Right.
explained.
Right.
So that's how you do it. Almost with all metals on the planet, when you want to produce them, if they are in the form of oxide. And on the moon, you have this problem that there is no carbon there. And it will cost you today, it will cost you around $1 million per kilogram to get something from Earth to the moon. It's a pretty expensive trip. And we need to produce thousands of tons. And that has to be economically viable.
Of oxygen.
Of oxygen.
Mm-hmm.
So we're like, okay, we need to rethink of how we're going to extract the oxygen from the metals because using carbon is a no-go
Mm-hmm.
in our minds. And we literally, open the periodic table, scratch our heads, and started to work. And this is how we came up with several novel approaches to extract and separate the oxygen from the metals.
Mm-hmm.
In chemistry, this process of extracting the oxygen or like separating the oxygen from the metal is called reduction.
Okay.
It's like the opposite of oxidation is reduction.
Okay.
So you say that you reduced the iron oxide, and you got iron and you got oxygen.
Does that have any connection with reduction in cooking, or is two totally different things?
I think it's different.
Okay.
I don't know. I'm not an expert in cooking.
Okay. So just to again put this in simple terms, so it's really expensive just to get to the moon, right? Just the amount of oxygen you have to carry on there because it's so expensive to extract oxygen even while you're on the moon, right?
It's expensive to get to the moon because to get mass whatever weight you want to the moon because of the rocket equation.
Right.
Okay, we call it the tyranny of the rocket equation.
Mm-hmm.
So for every kilogram you want to send to space, you need propellant.
Right.
Okay. Now you want to add another kilogram, you need more propellant. But you also added more propellant. So for that propellant, you need even more propellant. So very fast, it goes exponentially up.
Right.
And this is why most of the mass is just propellant and oxygen.
Yeah.
And not what you actually want to carry. And this is also why, I don't know if you ever noticed this, but all of the launching system that takes satellites and whatever, they always have at least 2 stages. It's not just like one rocket that goes all the way up, puts satellites, and that's it. You see that like along the way, the first stage breaks off,
Mm-hmm.
and then the second stage continues to get rid of that dead weight.
Okay.
And that's like a must. There's no way. I mean, there are like some conceptual designs that to do something like that, it's called single stage to orbit, but this is sci-fi, single stage to orbit at this point.
Okay.
So for the same reason, for example, Starship will have just enough propellant to get that mass to orbit,
Mm-hmm.
and that's it. Then it will be empty in orbit. Then it will have to wait in orbit for additional starships to go up
Holy
and
shit.
refuel it,
Oh my god.
so it can continue to the moon or Mars.
So it gets outside of the Earth's atmosphere. It just hangs out there for whatever,
In
however
orbit,
long.
yeah.
Yeah. And then another rocket comes in there with more.
Another, for specifically if they want to land on the moon, that will probably be something between 6 to 8 additional rockets that will have to come one after the other to refill the first one.
Holy shit.
Yeah.
This is cumbersome.
Yep.
Okay.
So that first rocket now can go to the moon,
Mm-hmm.
and let's say it landed on the moon and now it's empty.
Mm-hmm.
So you
Empty
need,
of propellant, right?
yeah.
Okay.
So now you need 6 or 8 launchers to refuel that, but each of these 6 or 8 launchers that comes from Earth will need 6 or 8 launch. Okay, you get where I'm going. So
This is tyranny. Okay.
yeah, yes,
Okay. So the idea that you guys is that you fill in the void there by developing a system that's easier or less expensive to extract oxygen from the minerals on the moon.
yeah. Now there are solutions. Obviously, in the Apollo era, they did that. Um, you know, do that. Sorry, they send so many rockets for each leg. So what they did is that for every leg, they just launched like a smaller part and a smaller part and a smaller part, and you see that the final part that went back to the moon was just a tiny capsule.
Mm.
Um, Now with Starship, the idea is to have a fully reusable system. This is how you drive down costs in
Mm.
space. Not only that, but one of the ways, because think about, launching something to space. The way it was done before Elon Musk was that you launch something, you deploy it in space, and then the rocket just burns in the atmosphere.
Okay.
Now you have, think of you sitting in an airplane, okay, and I don't know, going to New York, and some during, I don't know, like 30 minutes when you're over the Atlantic, 30 minutes before arriving, the captain says, everyone, get your parachutes, everyone jump, and the plane just crashes. And this is how you get to places. Think of how expensive your ticket would be, because
That's not the first thing I'm thinking about, but go on.
yeah. Yeah, but from that
Fuck the
perspective,
plane.
think about that. Like every flight, the tickets will have to cover also for the cost of the airplane itself, which is insane.
Okay.
And this is actually the story that
What
Elon
are you,
Musk
some
tells
sort of
when
insurance salesman? Yeah,
yeah.
go on.
Yeah, that's also insurance. By the way, insurance in space is also a big deal. It's also a big business that now is growing.
Okay.
But anyway, so this is a story that Elon Musk tells when he thought that when he flew, I think it was Las Vegas to LA or something like that, and the ticket cost him $40 or $45. And it's like, I'm sitting on an airplane that cost like $200 million,
Mm.
and I paid a ticket of $40. How come?
Mm-hmm.
Okay, so this is one of the reasons. And
Because the plane it's not
yeah,
single
so
use. Right.
if you have it's not only reusable, fully reusable, but that you can do it fast, meaning the Starship lands, get refueled,
Mm-hmm.
launched again.
Mm-hmm.
You don't need, because today they have the Falcon, which is also a fully reusable vehicle, but it's limited. It can fly only 10 to 15 times before you retire it. And every cycle takes 2 weeks. You need like refurbishments, etc., replace some parts. So the idea with the Starship is that you don't need that. Just land, you refuel, you go up again. Land, refuel, go up again, hundreds of times.
Mm.
And eventually to rate it like Boeing 747. Okay.
Wow.
And when you're at that point, this is the point where it will be cheap, and you're actually paying only for the propellant, for the oxygen that you need to refill, and for maintenance, of course.
Yeah.
But this is the idea. There are other reasons for this, but I think that in when it comes to what we're trying to do, that's pretty important, because this is where the idea of getting that oxygen from the moon come to play, because you can get that oxygen waiting for a starship in orbit instead of it to take everything from Earth and
Okay.
having so many additional launches just to refill the first one.
Okay.
Because getting something from the moon will require more than 20 times less energy from the moon to orbit, to low Earth orbit, than getting that same something from Earth to low Earth orbit.
Right. And that would be because
Because the gravity is only a sixth of Earth and you don't have an atmosphere. So escaping the lunar gravity is much easier than escaping Earth.
okay. Then what it would be a carrying all that extra weight on Earth that you assume wouldn't be
Yeah,
there to extract on the moon.
yeah,
Okay.
yeah. So this is why to do this, and also of course when they're on the moon, so you can provide oxygen, and also for the future Martian missions as well. But that's
It's just taking the same idea and
do that on Mars. We tested our technology on Martian soil as well, simulated Martian soil.
that was here in Israel, right?
Yeah.
Where exactly?
So we got Javier, so we got.
Oh, wow, that's like in the center of the country.
Mhm.
And the soil there is similar to what it
No, so we work with it's called a simulant. It's a simulated lunar regolith. We have a provider, a lab in Florida and a lab in Colorado that
Mhm.
produces the simulated lunar regolith, and we work with that because we know pretty well how the lunar regolith, from what is made of. NASA brought back nearly 400 kilograms during the Apollo era
Mm.
back to Earth.
Okay.
And the minerals are the same minerals like here on Earth. You just need to mix them in the right ratio.
Did you see this stuff?
The real stuff?
Yeah.
No.
Ah.
I mean, I saw one of a real Apollo 12 spacesuit, and you can see the regolith on its legs. So that's probably
What does it
correct.
look like? Just regular dirt?
Just dust, just gray dust, ultra fine. Ultra fine. Actually, it's a really nasty material because it's super fine, and like each particle, although so small,
Mhm.
if you look it under the microscope, looks like broken glass, like
Okay.
super angular, super sharp.
Oh.
So it's extremely abrasive,
Mm.
um, and electrostatically charged. And it's a mess. I mean, this is actually a big deal. This is something that NASA is now trying to solve with all sort of different technologies, because when astronauts will go there, they're going. It's a big deal. I mean, you can see at the Apollo suits, you can see how it like eaten their suit into their suit because it's so abrasive.
That's scary.
Yeah.
If you're just walking around and this thing is tearing your stuff to shreds. Or maybe not. I don't know. But is that more or less the picture? Like,
Yeah. So they have developed all sorts of solutions for this, like they wire the the suits and whatever machinery they want to operate on the ground there, and in a way that they can like turn on a charge and it repels the particles because they are also electrostatically charged.
wow.
It works pretty well. I saw this. Um, Also, a very important thing to do when we're on the moon is to pave the area you want to work in, so you won't have the dust flying all over the place.
What do you mean? Like, build a road?
Yeah,
Okay.
yeah. And also, landing pads are going to be very important.
Does this stuff exist already now?
No, but there are technologies that are being worked on to deploy this
Man,
in the coming years.
it's amazing. It is really like building a civilization from absolute scratch.
Yeah, although on the moon it will be very limited. Uh, In a sense, probably in a way similar, to the stations we have in Antarctica.
Mm,
So they're not going to be completely self-sufficient.
yeah.
Uh,
But there's I'm actually it's funny that you mentioned that because I'm reading now a book on it's called Endurance, the book about Ernest Shackleton. You ever heard of
yeah,
it? Yeah.
sure.
And there, I mean, it's horrible what those guys had to go through.
Hmm.
But at least they had penguins and seals and stuff to kill and eat.
Yeah.
I don't that I don't think there are any moon penguins, are there?
No,
No.
not that I know.
So
No,
it's
no.
really from
Antarctica,
scratch.
yeah, no, it's really from scratch. I, by the way, I had a chance to be in Antarctica
Mm,
for 2 weeks.
where?
Um,
How?
I took an expedition ship from Ushuaia. That's the southernmost town of Argentina, like the
Mm-hmm.
tip of South America.
Mm-hmm.
And you have all these expeditions that you can pay a certain amount of money and go on board and join.
What was it like?
Pretty amazing. It's an experience I highly recommend to any human being
Yeah.
to
Wait,
have.
when was this?
2012.
Oh wow,
Yeah,
long time ago. Okay. I mean,
10 years ago. Yeah.
um, so you were there for 2 weeks?
The whole trip was 2 weeks. So you have 3 days of sailing there from South America to the Antarctic Peninsula
What kind of a boat were you in?
in icebreaker. Those are relatively a small one, so only like 4 stories high. Um, an icebreaker.
But these things are made to withstand, ices bumping into.
Yeah, so we had like the main captain, and we had like a specialist captain who was an expert in going through icebergs. It was a ride. It was a wild ride, I'll say.
Yeah.
Yeah, you have like 3 days. You go south, and then you're in Antarctica, and you're every day you like change locations, and you take like these rubber boats. You go to the beach, and you walk around. Um, and then 3 days back. But the 3 days of sailing is pretty hardcore because
Yeah.
you go through what's called the Drake Passage, which is where the Atlantic, Pacific, and Southern Oceans meet, and it is the most violent
Right.
piece of sea in the world,
Right.
with average wavelength of like 20 or 30 meters.
Are you riding these waves?
Yeah, so you have only 2 to 3 months during the year that you can go there because this is where it's most calm. But still, there were some situations you have like buckles in bed. Like you're
Oh.
like, okay, buckle yourself up. And we had a small window. You look through the window, and it looks like you're in between mountains. It's pretty scary. And the ship goes like sideways, right and left. Like you're almost 90, 90 degrees to the left, 90
No.
degrees to the right. Not really, but this is how it feels. Um, and yes, we had one day that we went into an ice field, and the the specialist captain took the lead, and it was, imagine like the way an icebreaker work is like it has a huge blade
Mm-hmm.
beneath it, so it just goes over the iceberg, and then the weight of the ship just break it.
Mm.
So
Mm.
it's like you go up, 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 and then bam, you fall. And you do that once, you do that twice. It's pretty exciting. It's like a ride in the amusement park. You feel like you go up like really high, and then boom, everything falls. But then you do it for 8 hours straight, and it becomes very annoying.
How do you sleep in this kind of environment?
No, so most of the time it's okay. It's not like that harsh.
Okay.
For most, it was very hard with food and nausea and stuff like that. For some reason, it didn't get to me. So I
Okay.
was okay. My friend, I went there with a friend. He was in bed for 3 days, didn't get out of the bed. It says so. I ate his meals for him. Um, yeah, that was pretty hardcore. But then you get there, and it's like you're in a National Geographic episode. Seriously, and the animals, they don't care about you,
Right.
because in opposed to the rest of the world, they don't know what humans are, so they're not
Yeah.
afraid of you.
Yeah.
So they're like, you can stand next to them, and they don't care. Uh,
Wow.
and it's amazing.
Where because I'm assuming there's not really that much um buildings and roads and all this kind of stuff.
No, there's nothing.
There's nothing.
Like a few stations, research stations
So where do
here
you
and
sleep?
there.
You
No,
don't sleep.
you go back to the ship
Oh,
to sleep. You don't
okay.
sleep there.
Okay.
Yeah.
Okay. Because yeah, I mean it's all just sort of ice.
Yeah. It's no, you have land and you have snow and ice on that land. And it's very cold.
Yeah.
Actually, it wasn't that bad because we were very well prepared with the equipment, like 5 layers. And
5 layers.
yeah. But during that time of the year, the temperatures they range between 0
Mm-hmm.
to -30. That's like the hot season, and it's very like it can change dramatically very fast.
And how much sunlight did you have?
Oh, that's the hard part.
Yeah.
It's
No, the rest is fine.
no, that's 24/7 sun.
Oh,
The sun never sets during that time,
holy shit.
so it just goes around you like circles. Like, and it goes. It looks like it's going to set, but then it goes up again, and just circles around you. And that's actually a very it's very hard mentally, um because at some point you crave for nighttime,
Yeah.
like something you just craves for, to see the dark sky.
Mm.
And when we got back to Ushuaia, which is also, it's very down south, so
Mm-hmm.
you have like during summertime, which is like December,
Mm-hmm.
um they have like 2 or 3 hours of night.
Yeah.
Sun sets at like 11 p.m. and sunrise at 2 a.m., 2 3 a.m. But still, these 3 hours were like magic,
Yeah,
They're
of
like
course.
crave for it.
Yeah.
Yeah.
We, I mean, when it's sunny all day, what is it that drives someone crazy or uncomfortable? Is it like the fact that you feel you need to be doing something productive, or
I don't know.
what?
Just I don't know. I don't know. I can't explain it.
Yeah.
You just feel a crave to see the dark night, to see
Because
like the dark
yeah.
sky.
Are you the kind of person that if you wake up, let's say at like noon on a weekend or something, do you feel bad that you like there's only so little you've got, instead of, I don't know, 12 hours of daytime, you've got 7 hours, and you feel kind of bad about that? Does that ever happen to you? Let's say,
Um.
like, go back to your partying days, when
Yeah.
you'd go out to party until 4 in the morning or whatever, come home, sleep, wake up at 1. Did you feel
Mhm.
good or bad when you woke up at 1? I always felt like shit.
Yeah. Bad. Probably.
Yeah.
Today I would feel good because it means I had a chance to sleep for so long.
Yeah.
Sleeping is very important.
Yeah. Yeah.
Like really, it's like eating. This is how I see it.
Sure. Yeah.
You just need that in order to be productive.
Yeah.
And if you can have a good night's sleep, it just means that you can work on overdrive that day.
Yeah. Yeah.
Um,
Yeah. Man, what? So, all right, I'll move on from Antarctica, although no, because it's fascinating, man. But so what exactly would you have this sort of lunar module thing going on in the moon, right? Like, have you guys actually built one of those extraction
yeah. So
facilities yet?
uh, we're, we're we built a small system in our lab.
Yeah.
So we already demonstrated a while ago that you can put some lunar regolith inside and get oxygen.
Mm-hmm.
We managed to produce that. We also, as a byproduct, we get the metals
Right.
in the process.
And this was that sort of this business that sort of rose by chance, right? Of a new way of
Yeah, not
being able
exactly
to
by chance. This is
ah
it was partly by chance, partly designed by design. Um,
this
because
this new way of extracting steel.
of extracting metals in general,
Mm.
not just iron for steel.
Mm-hmm.
Because I mean, it's obviously making money of selling oxygen from the moon is a business that today has no market.
Yeah.
Okay, because there are no lunar bases yet, and the operations are not as significant yet. Um, and it will take some time until this lunar economy will come to life, and
First, they need to pave the roads, and then
you
you
need to
can.
pave the roads.
Yeah.
And we knew that we don't want to rely on government grants and investors for, I don't know, a decade
Yeah.
now. That's too risky. We wanted to be able to create a short-term business,
Mm.
a sustainable business in the short term.
Yeah.
And we assume that, okay, if we're going to come up with novel methods to extract the oxygen as a byproduct, we're going to get the metals. So it might be interesting to see if these technologies can be relevant for as what we call terrestrial applications. That we can use these methods to extract all sorts of metals here on
Yeah.
Earth, because these are big industries.
Yeah.
Steel, copper, nickel, silicon. Each of these, the words I just said, is like more than $1 trillion industry.
Each
Uh,
one.
yeah, steel maybe more, the others maybe a bit less, but yeah, I mean these are very big markets, and they're growing, and they are the foundation of our civilization. These metals, these materials,
I mean, these are the things that obviously the insides of our homes and buildings, cars,
everything,
everything.
everything. Steel is in everything, and if you don't have it, like everything you consume, you use, whatever,
Mm.
either has steel in it or what made it has steel in it. Okay, with no exceptions.
Let's just walk through a typical day. So, bed, steel inside. I guess in the springs, right? Okay.
Yeah,
Shower head.
the shower head. It probably has. I mean, the whole building has
Okay, let's just start with
steel
that.
rebars. The whole building in your car, like
Forks, knives, all that stuff.
most of it is made of stainless steel. Yes.
Yeah.
Almost all of the equipment you use has stainless steel part. All the screws and bolts you have everywhere are made of stainless steel.
Yeah.
Um,
Okay, so it is rather essential.
yeah, the food you eat, so probably the
Mm.
machinery that did whatever with it had
Mm.
have a lot of steel in it. The trucks that took it from place, the ships that took it from place to place has steel
Okay.
in it. Yeah. So just to give you a quick pie chart on steel. So
Yeah.
nearly 50% of steel goes into construction,
Okay, that makes sense.
buildings, um, bridges, everything.
Mm-hmm.
Then you have 20 to 25% goes into the automotive industry,
Okay.
cars, trucks, etc. And then the rest divides between machinery to home appliances and all sorts of stuff.
Yeah.
And, so this is how it's divided.
Right.
The last year, uh, the industry produced something like 2 billion tons
Okay.
of steel. That year. Um, it's a lot.
It's a lot. Yeah.
Yeah, it's a lot.
Okay. And uh, before, just like something I was wondering about with you is that do you ever feel lonely about what you do?
um,
Like selling oxygen on the moon, and everyone's like, "Fuck does that mean?" You know?
yeah. No.
I mean,
So.
entrepreneurship is a rather lonely thing to begin with, and then you're out there thinking about
Mhm.
what's going on outside of the Earth, for God's sakes.
Yeah. So I wouldn't say I feel lonely because I have my whole team with me,
Yeah.
and there are a lot. I mean, we're part of groups, like bigger groups that are dealing with these stuff. You go to conferences
Mm.
in Europe and in the US, and you meet your friends from other companies and other space agencies
Yeah.
that deal with what you're trying to do. So I wouldn't say I feel alone on that front, but as a CEO, you feel alone. That's part of the role. So on that on that end, yes. But not from the perspective of trying, to deal with oxygen, but from the perspective of trying to lead a company. That's yes.
Yeah, yeah. Because you take the decisions, and
Yeah.
it's not necessarily understood by everyone, I guess.
Yeah.
Or the weight of it is felt by everyone.
Yeah.
Yeah.
Yeah. Exactly.
No, I before we talked, I was trying to imagine, just you going to a dinner, right, with some friends, and like, so what do you, what do you
Talk
have to,
about.
Jonathan? And I'm like, well, you know that thing, oxygen, and you know that thing, the moon. And I was like, yeah, yeah,
Yeah. No. So we already passed that.
yeah.
That
So people
introduction.
people get it as a concept in the
Yeah. I
daily
mean,
life.
in the early days, um, I did get a lot of, man, why are you wasting your time? I
Really?
mean, yeah. Um, Today it's like obvious because
Yeah.
we got we are backed by the space agency, and we managed to raise money from like legitimate investors. No, and big corporates.
Yeah.
And we have a mission to the moon in 2.5 years. We're going to send a small system of ours to the moon.
Yeah.
Yeah,
Wow.
mid 2025. Yeah.
Is anyone from your team going with that mission, or it's
No, it's a robotic mission.
okay?
We're going to send a small box. Imagine like a shoebox.
Mm-hmm.
In that box, we're going to have our small reactor, and small shovel is going to put some lunar regolith inside. We're going to close the hatch, heat the the furnace, and
And out comes oxygen.
yeah, and we'll measure the output of oxygen
Wow.
to show efficiency, etc. Yeah. Um,
It's actually kind of amazing that, I mean, what the significance of that little shoebox could be, right?
yeah. So if we're going to do this in mid 2025, we are, as far as I know, unless someone is working on stealth mode, we're going to be the first non-Chinese technology to do that, because the Chinese claim that they already did that a year ago.
Why claim? You don't believe it?
I don't know. No, they didn't publish anything about it. They just said it like in a headline.
Mm.
Um, so the community, the space resources community is, I wouldn't say skeptic, but I, I I'm not familiar with the report that like gets into the detail of that experiment.
Mm.
Um, Very high level, but yeah, at least let's say from the west side of the globe, we might be the first to demonstrate that. And more than that, we are a commercial player. We're not a space agency,
Yeah.
so that's also a big deal. That you go on top of a commercial mission to the moon to demonstrate a commercial technology to do something like that. That's because eventually you want to be able to pave that road commercially. That would be ideal, because that's the most sustainable way to do it.
Mm.
If we're going to rely on the geopolitical conflict between China and the US, it might happen. Most likely it will happen. But this
Wait,
will
what will most likely happen?
I mean, these more lunar missions, more technologies to be developed, lunar bases, etc. It will most likely happen because of that conflict.
Mm. Okay.
But if we want to also make sure it happens because of commercial reasons, that is like the ideal way to go about it, then that's key. And demonstrating a commercial mission that does that, that's a big statement beyond just the fact that it's part of our critical
Yeah.
path, to develop the technology.
No, it does. It does. If I'm reading you right, it does show a proven ability to do this on, without the largesse of a government saying spend whatever you, or not whatever you want, but here's a huge budget and go,
Hmm.
experiment until you're blue in the face, until you find something that works. Where you guys are much more constrained, but therefore much more effective, right?
Yeah.
because you skip so many of those sort of trial and error periods where it's sort of that are funded by the state, where you
Mhm.
guys are just
And it's not only that. I mean, when you're funded by the state, you're not necessarily going to be sustainable in the long term because you're going to be dependent on the state to keep on funding you for this. Now, if it's for the sake of defense and war, that will probably last
yeah,
for long periods of time. Like
yeah,
you see, most of the defense industry is for governments. I mean, their clients are governments.
yeah.
Um, but here, we're not 100% certain that it will be the case, and you can see this with companies that try to do similar things to what we're doing, and they have like a very clear path in their mind on how they're going to develop the technology and commercialize it, and et cetera, et cetera. And then they get some NASA funding or whatever space agency funding, and that funding will come with these strings attached, which means, okay, so you're going to do that experiment. And that experiment doesn't necessarily aligns with what you need to do in order to mature your commercial technology.
Mm,
So it like derails you. But you're doing this because it's money. I mean, you can cover your operation costs.
mm.
So you see companies that startup small companies that try to do that, and then they're like suddenly their life is becoming to jump from one project to another government project, and they are reliant on this.
Mm. So they're essentially just another arm of whatever government's
Yeah,
sponsoring.
and if suddenly the government decided to shut down that program, you're
They have to
you're
scramble.
gone.
Yeah.
So we don't want that. We have like a very clear commercial path
Mm-hmm.
to what we want to do, and we're going to stick to that path,
Mm-hmm.
whatever it means. Now, luckily for us, in Israel, the Israeli Space Agency is more commercially oriented than in other places for
Why is
many
that?
for many reasons. Many reasons. I mean, their budget is pretty small, and they're most of on that side, on the commercial side of things, they have these programs where they can fund a company to mature a commercial technology, and this goes under the mechanism of the innovation authority.
Mm.
And when the innovation authority examines what you're doing, they're looking very thoroughly also to your business model, to how you're going to penetrate the market. That's like a big deal of what you're trying to do. It's not only
Mm.
about the technology and the science.
They want to make sure that.
Yeah, now obviously they also have scientific missions, but this is not the case. We want to do a commercial.
Yeah.
We want to develop a product. Um, and they also examined us on that level to make sure that we understand how we're going to get into the market.
Yeah.
But
Was their interest more on the steel stuff versus the?
it was part of it. I mean, it was an important part to show that this technology can be applicable to short term use cases,
Mm.
even if it's not necessarily in space. It's important, and this is I get this sometimes, that why spend so much money on trying to solve something on the moon just to go back and then solve the problem in steel, and not instead try to solve the problem in steel.
Yeah.
And I say this is not how um, these things work, because I mean, to try and solve the problem of the steel industry, which is the one of the most carbon emitting industries in the world. Two, they are super sensitive to the volatility of energy prices, so they suffer a lot from that. And there's a geopolitical aspect, which is China taking over the market. and Western steel makers are losing their business, and steel is critical to defense and everything. And
Mm.
suddenly you can, countries like, oh, I mean, now we're dependent on China, So
Yeah.
this is already happening with other critical metals like silicon and copper and nickel and
Mm.
lithium.
Mm.
Um, so you have the importance of these industries, and I forgot my.
You were saying why is so people are saying solve the steel stuff first and then go,
Yeah,
but
yeah,
you're
yeah,
saying
yeah.
actually the
So
opposite
so
is the truth.
so in reality, many players are trying to solve that steel problem. I mean, there are even some very big projects that are trying to solve, the carbon emission part of steel.
Mm-hmm.
Um, you have in Europe several very big projects that were funded by billions already,
Mm.
and in the US, you also have some big projects. But these projects, with no exception, might reduce carbon emissions, but they are going to increase production costs, which
Mm.
then it's a big problem.
It's sort of that's kind of the thing that plagues the whole green movement to begin with, right? It's like yes, we'll reduce our carbon
Yeah,
footprint, but it's going to cost a fuck ton more.
yeah.
Yeah,
But
but
if you're now trying to solve this problem on the moon, which sounds like ludicrous, but let's say
mm.
the limitations you have on the moon are so extreme that you have no choice. I mean, if the solution we came up with, okay, almost by definition, because we also targeted to meet like certain efficiencies and cost of production, etc. So almost with by definition, you're going to beat the unit economics of the terrestrial industry
Oh,
if you solve it.
right.
But these are your limitations. This is where you can play.
Mm.
Okay, carbon out of the equation. I don't know, working under like certain pressures out of the equation. Like, you
Mm.
have such extreme limitations, so you must come up with real novel, and it worked. I mean, so we have one of the processes that we developed is surprisingly efficient in iron making here on Earth also. And I'm saying surprisingly because, we thought that we might be able to do something that reduces emissions, but maybe at the same cost or something like that. But no, it's you reduce the direct emissions to zero. You reduce energy consumption by nearly 50%, 50.
Wow.
You reduce production cost by 20 to 30%. And this is in the steel industry, regardless of carbon credits. I mean, when we show and we calculated, the numbers, and we did this like sensitivity cost analysis, we on purpose we completely disregarded carbon credits. We wanted to show that our competition is not the alternative green projects. We are competing with the blast furnace. Blast furnace is the main way how steel is
Mm.
made today.
Mm.
For every ton of steel produced, they emit 2 tons of carbon dioxide. Um, and we realized that it works. Okay, so we're doing this. It works. That was nearly 2 years ago. Then um, we filed a bunch of patents of this, of course, and we reached out to the industry to try and get their feedback, because back then it was. I mean, we're talking about a completely novel way to produce iron, and it's kind of crazy to think about it. I mean, humanity have been producing iron for 3,000 years. Who are we to come up with a new way to produce iron?
Mm-hmm.
Okay, but this is a new way to produce iron. And we were under the assumption that we're missing something. I mean, there's no way no one thought about this, because it's not simple to do, but to explain it is simple in a
Mm.
way.
Mm.
Um, I can't explain it now, but next month I will be able to explain it. It's just because of patents and stuff like that. But
You mean you're gonna close your patent, secure your patent within a month's time? Is that
It just the patent reaches a certain level, then it's
okay?
public.
Okay.
But
So
let's say it's very simple, okay? And we're like, okay, how come this works and no one tried this before?
right.
There must be a reason. So we reached out to the steel industry. I had a call. It was nearly a year and a half ago with ThyssenKrupp Steel.
Okay.
Okay, ThyssenKrupp Steel. It's a subsidiary of ThyssenKrupp, the conglomerate in Germany. It's the biggest steel maker in Germany, second biggest in Europe. Their production site is the fourth largest in the world. It's a big steel producer.
Okay.
And somehow I managed to arrange a 15 minutes call some Friday afternoon with their CTO.
Okay.
Oh, he gave me 15 minutes to pitch him what we're doing. And I'm on that call and we're talking about this. And the 15 minutes turned into nearly an hour and a half or something
Whoa.
like that. Yeah. An hour, I don't remember.
Liar.
exactly.
He didn't have 15. He had way more than 15 minutes.
Yeah. But yeah, it was probably end of day for him. I don't know. But it was very exciting because on that call I learned that we actually have a novel process to produce iron that might bear a huge potential to decarbonize the steel industry and also reduce production cost.
That's wild.
It's crazy. It's crazy. I mean, went out of that call puzzled. I was like, whoa.
Not
What
excited.
just happened? No, I'm I'm very cautious
Okay.
with being excited about things.
Okay.
I'm super positive all the time. I'm like
Mhm.
optimistic about everything. I
Mhm.
think that everything will work. But I'm very cautious, to not get excited about things. Um,
Because I have this lingering question in my mind, and now I'm gonna be let down, I think, by the answer, but which is why aren't you like some $1 trillion company right now? If you can do what you claim to do, you know what I mean?
no, because I mean, we need to scale up the technology. So we're doing this in the lab. That's okay.
Mm-hmm.
ThyssenKrupp produces 50,000 tons of steel per day.
Right.
We went there 2 weeks after that call. We went there,
Wow.
myself and half the team,
Okay.
to meet with their VP R&D and his team and discuss scale up and to see the place because there are no facilities like this in Israel.
Right.
And the Germans, the way they measure the size of their production site is by how many times Monaco fits inside.
Really?
Okay, so their site is 10 times Monaco. Yes.
No way.
Yeah. At
It's
least,
that big?
yeah, it's pretty big. Um, and yes, I mean, that was an experience. I mean, we walk there, we see the systems, the blast furnaces. They're like 100. They have 6 blast furnaces. Each of them is 120 meters high. Um, it's big. I mean, the
Wow.
heat, the energy,
Where
it's
is this?
intense.
Where is this in Germany?
It's like an hour, 40 minutes north to Düsseldorf,
So yeah,
western side of Germany.
Dusseldorf.
Yeah,
Isn't that next to Holland?
not too far. Yeah,
Right.
yeah.
Oh, west. Yeah. Anyway,
West. Yeah.
I have this problem where someone will ask me what direction they're going in, left, right. I'll say left, but I actually mean right,
Mm-hmm.
and I'm adamant that like left is right, and it happens to me
Yeah.
way too frequently. But I actually do know what left is and what right is and what west is and east is. I don't know why I'm telling you this, but okay.
Yeah.
So
So
you went there.
we went there. It's pretty big. I remember that when we walked out of there, like the team were silent. We're like shocked because the silent. We're like thinking, "Whoa, what did we get ourselves into?" It was so big, yeah. But so you need to mature the technology to that level,
Mm.
and that is not going to be an easy feat. I mean, there are many challenges along the way that can even be a no-go. Um, so as you mature the technology, you de-risk and you overcome more and more of these potential no-goes. And and also the valuation of what we're doing is dramatically increasing.
Yeah.
Um, so why aren't we a $1 trillion company? We're not yet, just not yet. And that even before getting into the fact that these technologies are applicable to copper, nickel, zinc,
Right, right,
chromium,
right,
silicon,
right.
and others that we're working on as well.
Do you have a background in this?
Not really. My official background has nothing to do with what I'm doing today.
Okay.
I did study some aerospace engineering. I'm saying some because I never finished the degree.
I thought you were gonna say like I watched 4 YouTube videos.
No, no, no. I studied it at Technion. I started, the Atuda, Mostur Atuda,
Okay, so that's
and
like an
that you become an engineer in the military.
in the military.
Yes, I didn't have the medical profile. I really wanted to be in the infantry for some reason, and I didn't have the medical profile, so I went there. In Technion, started studying the I think 5 or 6 semesters,
Mm-hmm.
like nearly 3 years. And then one day I managed to improve my medical profile.
How?
I did. I have a back problem, so
Okay.
this physiotherapy for like 2 years.
Okay. Okay.
A lot of doctors, a lot of things, and just one day they approved it, and I got the profile I wanted, and that was like some afternoon, I think Wednesday or Tuesday or Wednesday, and the next day, the morning, I went to the office of my unit, like, bye bye, I'm going to the infantry now.
Wow.
Yeah, and like I can always come back and complete the degree later, which I
Yeah.
never did eventually. But I can always do it, but to be in the infantry, it's like this is the only chance. I can't go back sometime in the future and do that.
Yeah.
So I joined the Nachal Brigade. Spent there a few years. I was an officer. After that, I did some other uh, roles in the armed forces. Spent nearly a decade
Wow.
in the armed forces. And yeah,
What
uh,
years were this?
20. I finished everything at 2015, I think.
So
Something like
you
that.
you joined in 2005?
2006. 2016, 2015, 16. Yeah, almost a decade, a bit less than a decade, like 9 years or something like that.
So then you were around for 2008, 2009?
No, yes. But during that time, I was in the Technion.
Ah, okay.
Until 2009, I joined Nachal.
Okay, so 2012, was that a land invasion? No, sorry, that wasn't a land invasion.
Yeah, but I was in Nachal. I was in the military only until 2012.
Okay. So what was 2015, 16?
Other stuff. And I always wanted to
You
do
were
some.
planting trees in
Yeah,
Iraq.
no. I always wanted to do something in space. It was like a bug in the back of my mind.
Really?
Yeah,
As far back as
as my grandmother passed away 2 years ago, and when they cleaned up her apartment, they found this drawing of mine
yeah.
from age 5 or 6.
Yeah.
Okay, yeah, you can see like Earth and rockets and the moon and all the planets. So that's like my proof that it was in my mind
It was
since it
there.
was always there. Yes, actually, my wife, she framed that as a surprise, and now it's in my
Sweet.
office. Yeah,
Wow. Wow.
it's a reminder.
Do you remember though, as a kid thinking about this stuff?
Yeah, yeah. It's maybe it sounds like cliche, but I always wanted to be an astronaut.
Funny.
Yeah.
What about it? What if you can remember back then what the dreams were like and the fantasies were like? What
Wow, that was a while ago. Um,
it's a strange thing for an Israeli kid to want to be an astronaut.
yeah,
I mean, it is and it isn't. Because on the one hand, in tell me if I'm wrong, but growing up in this country, you don't have those sort of heroes to point to and to say, "Oh, look, there's the I don't know the Shlomi from
Mm-hmm.
Falsaba or whatever that went to the moon,
Yeah.
and I can follow that guy's path. Like there's a pathway for me to get there.
Yeah.
And he speaks like me, and he studied the same things, and so on and so forth. Now, on the other hand, you could say those kinds of dreams are relevant for anyone, right?
Mm-hmm.
Especially in a country where, like, so for example, Ilan Ramon, right,
Mm-hmm.
who's the Israeli astronaut that died. Was it Colombia?
Yeah.
Right. He grew up in Israel.
Yeah.
There was at the time anyway, no way for him to get to the moon within Israel, but he found a way somehow to get to the
So
U.S.
space station. Yeah.
Sorry, yes,
To
space
space.
station.
Yeah.
So was that someone that you looked up to?
Yes, but I mean, it started before that.
Mm.
Um, I it might sound funny, but it actually came from science fiction shows
Okay.
and gaming. Like my favorite game was StarCraft.
Okay.
Please,
Can't say I ever played.
yeah. So and by the way, back then for a while it was the most popular game in the world. Like you had
Mm.
um like competitions.
Yeah.
You had a league. It was a big deal. Uh,
You were in those things.
no,
No.
no, but I really liked it, and
Yeah.
I really like, still like sci-fi. So originally it comes from that.
Okay. You
Yeah,
think you think you'll ever go yourself?
for sure.
Yeah.
Yeah, at some point. Yeah. I think that it will be way more like a casual thing that people imagine in the coming decades.
I
To
don't know,
go to
man.
go to the space station, to go to the moon. I mean, it's not going to be a work for everyone, but it's going to be something that people do as a living. You're going to have these bases and infrastructure that will have to be maintained, and exploration,
Mm.
a lot of scientific missions, space. Now we have two space stations now. We have the International Space Station. There's the Chinese Space Station.
Mm-hmm.
There are going to be at least 5 or 6 space stations in the coming decades. Most of them are going to be commercial,
Mm.
and you're going to need operators, and I mean, you're going to have thousands of people in space in if I had to guess, like in 20 years.
Wow. Wow. Do you?
But again, I'm always the optimistic, so
No, that's good. That's
but yeah,
good. I'm also optimistic, but about about other things,
yeah,
I don't ever think about.
yeah.
I'm just like thinking what it would be like to pack my bags. Like what do you prepare? What do you put in the suitcase?
Oh wow, it's
Space suits that don't get fucked up from crazy soil.
yeah. No, so that's probably part of what you get, when you buy the ticket. But yeah, I mean, there are a lot of things that you don't think about it that you'll need to deal with in
Yeah,
space, like
yeah, yeah.
food and sleeping. From what I heard, sleeping is horrible in space.
How
Um,
come?
First of all, like there is no lying down.
Mm,
On the moon, it will be different. Actually, I think on the moon it will be much easier. But when you're in the space station, just like floating around,
yeah.
microgravity, there is no lying down. So it's just like floating, and you need to strap yourself to some. It's not to the floor; it's to some plane. Okay,
Right.
um, because there is no gravity, so you have all sorts of like different stuff that happen. Like, um, did you ever see water in the space station that looks like bubbles?
Okay.
Yeah. So gases can behave the same. So like when you sleep, there is this risk that you get like yourself gradually in a bubble of carbon dioxide because carbon dioxide is heavier. So what happens here usually when you breathe it out, it like goes down and there's like circulation with the air. So so if you're in a place that has no gravity, it can um, the circulation has to be uh, um, actively happen. I mean,
Mm-hmm.
something have to actively create that circulation.
Mm-hmm.
Otherwise, you can choke in a bubble of carbon dioxide.
Okay. Wow. That.
Yeah, just I mean, it probably won't happen, but just to give you a sense of the stuff that you need to think about when you're in
Just trying to get to sleep.
zero G or microgravity. Yes.
Wow. Okay.
Uh,
I mean, it just when I was still stuck on being strapped to some flat surface. Like, what if you? I mean, everyone moves. Everyone moves when they sleep.
mhm.
But if you're strapped in, like you're just that's really uncomfortable, huh?
Yeah, I guess so. Yeah, from what I know, from what I read about, yeah, astronauts complain about sleeping.
Yeah. Let alone the choking bit.
Yeah, if that happened, they won't complain. But yeah,
Right. um. Let's talk about Elon Musk for a second.
okay.
What do you make of the guy?
Well, yeah, he's a pretty unique fella, controversial in many ways. Um,
Can I
um,
say I don't know what the hell that means. Controversial. Like everyone's controversial.
yeah, I know. No, I'm not. I don't think it is.
Yeah.
Okay, I'm just saying in the public eyes. Just reading. You have the fact that you have people who are for him or against him, like he's some sort of a soccer team. That I think it's ridiculous, but
Yeah.
this is just reality. So this is what I mean by controversial.
Yeah.
Um, and and yeah, I think in the perspective of time, like history wise, he's going to be a very important figure
Yeah.
in
No doubt.
history. There is uh a nice saying that I heard saying this. I think that was Robert Zubrin. It's someone from the chairman of the Mars Society in the
Okay.
U.S. Okay, so I think he said it. Nine 1492. What happened in 1492? You grew up in America. You know what happened in 1492.
Of course.
Yeah. So if you go to 1492 and you would open the paper, what you would read about? I mean, what would be in the paper? Many things happened in the paper.
Hmm.
There was like this big war in Europe. Some prince was murdered.
The Inquisition. Yeah.
The Inquisition, of course, that was also a big deal for us specifically.
Mm-hmm.
Um, maybe you'd find some small acknowledgement or whatever, like a small piece about that crazy dude who decided to go
The New World.
to the new world. Yeah.
Yeah.
Back then, it was like such a small, like non-important thing.
Mm.
And 500 years later, more, that's like the number one thing about this date
Right.
by far. It's like
Yeah.
so.
Yeah.
So I think that 500 years from today, no one will care about the war, or it won't be like as common knowledge as if today about the war in Ukraine or what
Mm.
happens in the Middle East or about Trump or whatever. That will all be
Mm-hmm.
nothing. But Elon Musk will be that one figure that is associated with our time
Yeah.
of being the enabler that made humanity a species that that lives beyond Earth.
Yeah. I mean, to go metaphysical for a second. So a couple of weeks ago, I caught like snippets of the podcast he did with Joe Rogan, and he's
Hmm.
explaining like what is SpaceX, the idea
Hmm.
behind it. And it's like um, that human beings should be an interplanetary species, and how important that is, and hopefully even one day to leave the solar system, right? And obviously that's important to ensure our survival, but more than that, he said that's a hopeful message for humanity.
Mm.
And I thought about that for a second, and I was like, that's a really profound mission to have for one's own life, because once we found out that life on this planet has an expiration date, right? The sun, I think I read, in a billion years,
Will
the
expand.
right, it'll be too hot for any life to be sustainable on this planet.
Mm-hmm.
So, once we understood that, the concept of nihilism, right, creeps in and says, well, we're all gonna die anyway. All this stuff is random and meaningless, and that has devastating consequences on our everyday life,
Mm-hmm.
right? Because once that thought kicks in, you do have to then struggle to find any justification for any of the things that we do.
Mm-hmm.
And to then say that, look, there's actually a chance that life doesn't have to end, right? And you open back that door towards a life of meaning, right? And that doesn't
Mm-hmm.
necessarily prove anything, right? It doesn't necessarily prove that what we do ultimately matters, but it certainly it it does undercut the argument that, and this is what the existentialist philosophers all argued about, which is like, there is no God, and so life is basically meaningless, but we're alive anyway, so what do we do? Well, now it's like, well, I'm not sure anymore, right? And you bring back some of that hope to our species, and I mean, that's such a profound way to dedicate your life. Like,
Mm-hmm.
that part I don't think really gets discussed so much when it comes to Elon Musk.
Yeah.
And what's crazy about him is, like, I think he understands this. If I sort of piece together other interviews that he's given, um, and the guy works like crazy.
Yeah.
He works like 100-hour work weeks for the last 30 years.
Mm-hmm.
You know, he is. You could say he's driven by this purpose, but he's also a slave. Like, now I don't feel too bad for the guy because he's got plenty of money and
Mm-hmm.
more than enough resources to say, fuck it, I'm done, right? But he just keeps going.
Yeah.
Working at this insane pace. Like, put aside all the money and the, people that work that much, that sleep in the factories of their, Tesla factories or SpaceX or wherever the hell he is. That is really the condition of a slave, like, to work that hard for that many years. So yeah, I have really just nothing but profound admiration for that guy. Like, that he really has dedicated his life for us.
Yeah.
All of us.
Yeah.
And people really, that there are really a bunch of people in the world that really, really dislike the guy. I don't understand it.
Yeah. Yeah. So, first of all, I don't think he sees himself as a slave.
He can't stop.
He can't stop. Yeah.
It's really as if there's some internal monster,
Yeah.
hitting
But
him with a whip, saying,
I,
"Keep going, keep going."
I
Keep
guess
going.
that it's also what, as an internal drive to do this and to make sure that that the candle of consciousness will be lit for as long as possible.
Yeah,
And I totally get this. And in a way, this is at the core of everything. This is a really good driver,
yeah.
and something I think about a lot in my small journey.
Wait, let's go there for a second.
Yeah,
What is it that drives you? I mean, it's probably many things, but let's.
there are many things. Yeah, so eventually, um, this thought of the meaning of our existence. In my eyes, it's an intrinsic thing, and we are here because um, just happens to be that we're here. And if we're here, we don't know if there are other possible consciousness in existence. So we have only that as an example.
Mm-hmm.
So let's see how we can make sure that we keep that consciousness alive as long as possible. I don't have any additional level of reasoning beneath that. This is just, the fact that this we have only one off, and we don't know what's beyond it. So let's not fuck it up, okay? And let's make sure we can have that candle on as long as possible, or as long as we understand better the nature of this existence, because at the moment we don't. By the way, this is also the same rationale I have for climate change.
Right.
Okay, I mean climate change. There are some debates whether how much we affect it. We don't. I think the consensus says that we do. But whether it's a good thing, a bad thing, you know what? I mean, why doing this experiment? I mean, the consequences of these experiments can be so detrimental. I mean, it's the the system that we live in, Earth, the biosphere,
Mm-hmm.
is chaotic. I mean, you do one thing here, you have no idea how it will affect the other thing there.
Right.
So let's try to not fuck it up and and minimize our effect on our effect on this environment,
Yeah.
at least until we understand it better.
Okay. So
So this is, but not in a way that will, on the other hand, okay, going back to climate, not in a way that will cause starvation and stuff like that,
yeah.
because there are some trajectories in the green
Right.
areas that will cause starvation if we take them.
And
So
the argument there, just to put a bow on that, is some of the measures that the green movement advocate would decrease economic growth. Economic
yeah,
growth is bad for poor people, and yeah, less resources for less people obviously just means
yeah,
more privation for.
and that takes me
But I just want to
yeah,
I want to press you because embedded in what you said, right? You said that the value of life or consciousness is intrinsic, but what do you mean by that exactly? Because I keep coming back to the issue of meaning,
mhm,
right? Which is we want to protect the life here on Earth, right? So
mhm,
let's protect our environment, and we want to, knowing that there is an expiration date on what's on the party that's going on here on Earth. Let's try to do as much as we can with the time that we have in order to ensure that this party doesn't have to end here a billion years from now or whatever the hell it is, right?
yeah,
Um, but the question still remains is the why, you know?
mhm, yeah. So okay, I can try and expand on that, but we'll we'll go to physics a little bit
Let's go to physics.
now. No, that's very high level. And most of what I'm going to say is, I think most of it is also part of the consensus.
Sure.
Some of it, at least. Some of it not. Um, so reality. Okay, we know that you know um, since like last century, quantum physics. We have that idea of how reality behaves. That you have a wave of all sorts of like different possibilities
Mm-hmm.
of what happens, and then when you meet with that reality, that wave collapses into one option.
Okay.
Okay, so for example, you probably heard the term the Schrodinger's cat?
Yes, but I have no idea what it means.
Okay, so Schrodinger came up with this thought experience to explain what it means. This wave of possibilities um, nature. So you have the cat inside the box, and there's a mechanism inside the box that, as it's closed, you have 50-50 chance that the box will kill the cat. I don't know, like a cyanide peel or whatever there that will kill the cat. Before you open the box, the cat is 50% dead, 50% alive. After you open the box,
Mm.
like you collapse the wave and you see what happens. It's
Mm-hmm.
dead or alive.
Mm-hmm.
But before you saw it, it's both of these things together. It's in superposition.
Okay.
It's both of these things.
Okay.
Now there are different ways to explain this. The way that makes more sense to me is a theory called the many world theories.
Mm-hmm.
It means that everything happens. There's like, let's say, like a split in the world, the universe. One went left to cat is alive, the other went right, cat is dead. For some reason, you are, or your consciousness is on the right one.
Mm-hmm.
Okay? For some reason.
Mm-hmm.
But the other part is also there with you, with your consciousness as well.
Okay.
Okay, so you have that many world theories. So it means that everything happens. And for me, it makes sense because when you think about
But everything doesn't happen, right? It's just the waves are there, but the potential.
yes, everything happens. Everything that can happen happen. Okay, and now you ask how come, and this is also in a way I think is a good explanation to how come we're here.
Mm-hmm.
Okay, and why we exist. Because it's a possible branch in that tree.
Okay.
So you have an infinite tree that everything can happen. So in that everything, one branch in that everything is us sitting here today talking.
Mm-hmm.
Okay, and consciousness in general existing. So because it's very hard for me to understand, I don't know what term to use, but like specificism. You know what I mean? Like that you have specific stuff.
Okay.
Okay, and opposed to not having specific stuff, like or all or nothing. Like this in between, like they have like specific stuff that the weight, the mass of the electron is exactly that, and pi is exactly 3.1415, blah 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 blah. These numbers matter because if one of these numbers was a bit different, we weren't here today.
Okay.
Now I think that these numbers are different in infinite variations. There's like this one narrow branch where everything fits and we can exist. So this is this is my idea of reality, why we exist. And I think
Wait. So
yes.
land the plane here for a
Yes,
second.
so
'Cause right now
consciousness.
I'm back. I'm right now what you've just told me is, again, we're back to the airplane, and the pilot's about to land the plane. It says, "Okay, everyone, get your parachutes." I don't know what the fuck's going on. So
Yeah.
am I landing the plane? What's going on?
Yeah, no. So just finish. So consciousness is just a phenomena in that infinity of options. So this is what it is. We happen to be here. We have it. So let's do our best to keep it. This is how I see things.
Okay.
Okay. Now I also have sentiments to my children,
Yes.
and I really care about their future. And this is like everything I said now comes from my rationing, for me rationing this.
Yeah.
Now it's the emotional part. It's not
Right.
about rationality. I really care about my children's future. I really want them to have a future that is good, that is a place where they will enjoy the same growth in the economy like we do today.
Mm-hmm.
And it's not a trivial thing.
Tell me
Um,
about it. Yeah.
yeah. So when everything comes together for me, and I'm like, okay, what I'm going to do in my life, I will try to pursue that. I will try to pursue a future where they have a chance to have, to enjoy the same growth rate, to enjoy a good life. Okay. And this also brings me to what we're doing at Helios and why oxygen on the moon and why it's still here on Earth. And it's beyond that. There is a big problem. I see it as a big elephant in the room that no one is really addressing or not adequately for sure. And that is the fact that we have a problem with resources, with metals specifically.
Mm-hmm.
Okay. We don't, to produce them at the right quantities to keep the growth rate of civilization requires a lot of energy that in some cases is going to be a challenge to get. Whether we care about the environment or not, we will need an infrastructure that can provide sustainable energy sources, because even if we don't care about the environment, we're going to end oil at some point, and it's not 1,000 years from today, it's less than 100 years. It's something that for sure will affect our kids. Um, or let's say, or if they will tear up Antarctica, so they might extend that for a little bit, because there are some speculation that there are a lot of oil reserves there. So maybe our grandchildren, okay, for sure, generations that we're going to know personally.
Mm.
Um, and even worse than that, many of the metals that we need, we don't have enough of them on the planet. Like literally, we don't have enough of this metal in a way that is accessible on the planet. Okay, so for example, copper. Copper is one of the most fundamental metals we need for everything you want to electrify. You need copper. You need a lot of
Mm.
copper. Electric vehicles, wiring of everything, solar panels. Doesn't matter. I mean, you need a lot of copper. So 100 years ago, and your average copper mine would have something like 15 to 17 copper content in it. Today, copper mining companies are fighting over mines with 0.3% copper content in it.
Well.
The material is depleting, and it's harder and harder to get it out of these minerals.
Mm.
So there's no way around it. I just can't see how this is sustainable in the long run. And again, by saying long run, I don't mean 1,000 years from today. Not even 200 years from today. I'm talking about our kids. And it's like it's simple math. It's not
Yeah.
some complicated, chaotic environment systems that you can debate about.
Yeah.
It's pretty simple.
No, there's an urgency to the project.
Yes. So what we are trying to do with the set of technologies that we developed is, one, in the short term, to see how we can reduce emissions, reduce energy cost to produce and refine the metals that we can do today. In short term, I mean 20 years,
Mm.
okay, 10 to 20 years. And in the long term, 30 years and more, to do what it takes in order to make mining beyond Earth economically viable. Because today it's science fiction, okay, to mine asteroids and stuff like that.
Mm.
By the way, it's not unheard of. The Americans and the Japanese already rendezvoused with an asteroid, took some samples, and went back to Earth. But to actually mine it at scale, to make it economically viable, that you can compete here on Earth, that requires a whole set of steps to take that will take several decades.
And a lot of oxygen.
A lot of oxygen in the way, yes, for sure. So when we think about what we need to happen in 30 years from today, and now you reverse engineer to today, and this is what we're doing today.
So, given the stakes,
Yeah.
for your kids, but for all of our kids, even for yourself, right? 10, 20 years, hopefully we're still around, right?
Mm-hmm.
You do have to then ask yourself, why aren't we all working as hard as Elon Musk? Especially for the people who like yourself who are devoted to these grand projects that really do impact every single one of us,
Yeah.
literally every single one of us. So these are existential questions that we deal with.
Yeah.
And so I come back to the slave thing. I mean, yes, he's the world's second or third or fourth, whatever. He's super rich. But I can kind of understand why that guy works himself so bloody hard. You know?
Mm-hmm.
Do you feel the same urge? I mean, how do you look at it?
To work that hard?
Yeah. I mean, I'm not saying you don't work hard. I have no
think
idea.
I work pretty hard. I mean, I don't know. I don't know what he's doing and how his work-life balance with his kids is. So I don't know what. I don't want to assume anything.
Yeah.
About how he's handling this. I'd say on myself that I do try to keep my family not from breaking apart.
Yeah.
So I do try to keep some work-life balance. Spend time with my family. It's very important. It's also very important specifically for me. I guess that for most, but for me, it's very important for my mental health.
Yeah.
To have that. Even though I can, like, the mind is always like running. You always think about the what you're trying to solve, and
Yeah.
we're like, it sounds very big, etc. But my day to day is in the trenches. You're in the trenches. You don't think about that big picture
Yeah.
every day.
When do you think about the big picture?
When things get really hard.
Yeah, right. Always.
And they do often.
Yeah.
And yeah, but when you're in the trenches, you think about raising the next financing round,
Yeah.
or hiring your, I don't know, the next engineer, or
Sure.
the logistics issue you have with materials that you should have got to run your experiments, and now they stuck in customs and whatever. I mean, seriously, I mean, you have
Yeah. Yeah.
these are the things that we deal with. That's
Yeah.
part of doing business.
Yeah. Yeah. No, but look, just another way of looking at this that I also kind of struck me as interesting was, so Elon made his fortune trying to tackle the biggest problems that we're facing now and we'll face hundreds, thousands of years from now. And then you compare that to someone like a Jeff Bezos. I'm adding another point of admiration for Elon. And so Jeff Bezos makes his money building Amazon, which is, the most sophisticated logistical company humanity has ever seen, right?
Mm-hmm.
The guy's clearly a genius. I mean, think about how complicated it is to click on a website and order a package from somewhere, and then from somewhere else in this one of the biggest countries in the world, it arrives at your doorstep the next day.
Yeah.
I mean, just the amount of steps the amount of computations that one needs to make in order to make that happen
Mm-hmm.
is crazy. It's actually funny because there was some big expose, I think, in the New York Times about how rough and how hardcore the work culture is at Amazon. It's like, what do you expect? Like, They're pulling off the impossible. Like
Yeah.
they cannot afford one single mistake along the entire
Yeah.
supply chain there. Like one mistake fucks that whole process up.
Yeah.
And I kind of wonder, like, any of those were those journalists who were writing that story. Do they have Amazon accounts and do they order Amazon? Which one do you want, right? But still, in the end, Bezos made his money off of um, our need to consume things, right? Consumerism, right? Whereas this guy is like, we've got bigger problems than wear my UGG boots, this winter. It's just interesting, the way people spend and devote their time on this planet, right?
Yeah.
And it's also cool that we live in a capitalist system that rewards both, but it does reward the one that's, in my opinion, more meaningful than the other.
Mm-hmm.
So yeah, I mean, the fact that you're spending your time doing this is pretty cool, man. What?
Yeah, I'm happy. I mean, I'm really happy. That would be the short answer.
Yeah.
That this is what I'm doing.
And you said you're an optimist, right? So
yeah,
would you say that you're bullish or bearish on humanity?
bullish.
Yeah.
Yeah, sure.
How come?
I mean, it can be very frustrating, to see how most of humanity is wasting their time on politics and stuff like that. Even here in Israel.
Sure.
I mean, I'm not saying that things don't matter. They do, of course. And what our politicians do affect our lives, of course. But I just don't see this as important.
Right. In the history book, 500 years from now.
In the history book. Yeah, in historical perspective, it's not as important.
Yeah.
Most likely. I mean, unless someone will press the red button sometime. But most likely, it's not as important. So, even, let's say, politics here in Israel. Okay, so elections. Obviously, I did my civil duty. I went I elected whoever, and that's it. I mean, I don't think about it anymore. I don't read the news about this. I don't have anything that I can do about it. Personally, it's if there's something that I can't do anything about it, or I know that I'm not going to do anything about it, I don't care about it.
Okay.
Because it does, obviously it's going to affect me, but it's not like I'm part of the system that I'm going to change anything. So I better, so I'm better, focused on what I can do, and where I do matter. And this is where I put my energy, because it seems to me that this, for example, politics takes a lot of energy from people. Like I don't know.
No, go for it. You feel that in your own life, that the people?
No, so specifically in my environment, people are less sensitive to that. So they I think they're more like-minded. They don't care about that as much. I mean, yeah, we might have political discussions in the office here and there, but it's not. We have. I think we have most of the spectrum in our office.
No kidding.
Yeah, we're very different from your regular startup company.
Yeah. Although, again, the things that you're dealing with do transcend the mundane political crap that
so
most people do. Yeah,
I think so. I mean, you're doing something that is of that importance.
Right.
Suddenly, suddenly feel
right
that all the other things that people are fighting about are
right.
I wouldn't call them stupid, of course, that these things, but it's just not as important, and it feels like just draws energy from you. So I'm not dealing with these things. And
well, you got a rocket to catch, right? You're going to the moon, right?
Yeah. and it's going to be a long ride.
When do you, seriously, I'm not joking, but when do you really think that you'll go to the moon? or wherever the hell you're going?
Probably late 30s.
How old are you?
No, late 2030s.
Oh,
Not
okay.
my 30s. I'm 35.
Okay.
So that I'll be probably like 50 or something like that.
Wow.
Towards my 50s. Yeah. Probably by then.
What? I'm just curious about what's with the timing. Why?
Um First of all, I mean in the coming decade it's not going to be possible anyway. Unless you're like a billionaire that is going to spend a big chunk of his money on
Mhm.
that, and I have no intention to spend so much money on that. In 20 or 30 years, it will probably be cheaper, or it will, I can do it part of a work trip or something like that. Um,
Yeah.
but yeah, for sure. I mean, there's no way I'm not going. I mean, I'm in the business, so so of course I'll take the opportunity if I'll have it in the future. Uh,
Do you find that what percentage of the people in your industry in your company are like minded to say, yeah, if there's a flight and there's a spot and I can
I think
perform?
most of the team.
Yeah.
There. Yes, we have a lot of jokes about it. Also, who's like the first to go when we have an opportunity?
Yeah.
Yeah, yeah, for
Yeah.
sure.
So also you have like a little what do you call it? Like a pool who's going to be the first to go?
Yeah, sort of. Yeah, but maybe it would be a good idea. We need to do like an internal ranking, so people know like who's first to go when time will come,
Yeah.
and it can that the ranking will be updated from month to month, so it will incentivize people
Yeah.
to work better.
Does the fact that you've been to Antarctica, does that help or hurt your case in your office pool?
I don't know. I won't remind them that.
Oh man. I think is there anything else you want to talk about? I think,
Yeah, I
we've
think we covered most of
covered
it.
a lot.
Covered a lot, yeah.
From the
Antarctica,
microscopic all the way to the metaphysical.
Antarctica to the moon. Yeah.
Cool, man. Well, thanks for doing this. This was fun.
Yeah, it was really fun. Thank you very much.
Cool, man.
Yep.
And good luck, obviously.
Yeah.
All right, man.